Hello guys, welcome to today's lecture. So we are going to discuss about the packet flow. So first we will see the packet flow inside home network, right? How does packet flows inside your home network? So we have taken a very simple topology. Let's say you have your laptop connected to your home router, either through wireless connection or through LAN cable, and then your home router is connected to public network, that is your internet, and we have facebook.com which is hosted over internet. So let's say in your browser, if you try to open facebook.com, what is going to happen? So this is what we are going to discuss today, right? So initially your system is going to generate the DNS query for the facebook.com, and your home router is going to provide you the IP address for the facebook.com. Once you get the IP address to the facebook.com, then your system is going to send the TCP SYN packet to the facebook.com to establish the TCP connection, right? Facebook is going to respond back with the TCP SYN plus acknowledgement packet, and then your machine is going to send the SYN acknowledgement packet to establish the TCP three-way handshake, right? And after that, your connection has been established. There will be packets flowing back and forth between client and the server. Now after TCP connection, these days we use SSL, right? So 85% of websites are using SSL connection. So after TCP connection, you will see your SSL handshake starts, right? That is client hello, server hello. And once your SSL handshake is complete, then your HTTP stream starts, right? You will see encrypted packets are going over the internet if you take Wireshark captures on your laptop interface, right? If you want to see SSL handshake, so we have a dedicated video available for that. You can go and check that out. And if it is going to be port AD connection, then after TCP connection, your HTTP stream will start flowing through the network. Okay, so this is very basic setup where we have shown the packet flow, right? You don't have any other switching or routing device except your home router, right? And we have next network, that is your legacy enterprise network, right? Now we will see how packet flow occurs in legacy networks, right? So we used to have private networks, we used to have DMZ network, your MPLS connectivity, to the headquarters. Then we used to have ISP, the public network where we used to get the internet connectivity. And then we used to have enterprise router, which gives connection to all these different networks, right? So in private network, you will see that we used to divide the segment, with the help of the VLANs, right? So let's say VLAN 10 represents HR department, VLAN 20 represents finance department, VLAN 30 represents DNS zone, right? So it is going to carry your local DNS servers. Similarly, in your DMZ network, you are going to have your servers which will be serving your websites to the internet users, right? And we name it as server VLAN. Then we have MPLS link through which we get access to our headquarters where we have our other servers, right? So that your users can log into those servers and can do their day-to-day work. Similarly, if you want to visit Facebook, you can get the access through your public network. So let's see how packet flows inside enterprise network. So initially there will be a ARP request if you try to access facebook.com, right? So initially what happens, let's say this is fresh setup, every machine is booting for the first time, right? So your machines will try to learn the MAC addresses. So when you type facebook.com, the very first thing is your DNS query, right? Your DNS query will go to the DNS server, right? And then you will get the reply that this is the IP address to which you need to make the connection, right? Now the very first packet, the very next packet will depend upon the ARP entries, right? So what will happen, your client PC is going to let me show you. Your client PC is going to do the bitwise AND, right? So what do you understand by bitwise AND? So it's like this, how your client PC will come to know that whether I need to send this packet to the gateway or I need to do local switching, right? Because it is going to generate the ARP packets. So for which particular IP address this client needs to generate the ARP packet, right? So let's say this is your router, and then you have your switch, and then we have client here, right? This broadcast domain is 192.168.1.0/24, and this is your gateway IP, right? 192.168.1.1, and then you are connected through ISP link, and you have your reachability to facebook.com. Now for Facebook, so this is 1.1, this is 1.2. For Facebook, you have received an IP address 1.1.1 from your DNS server, local DNS server, right? Now what your machine is going to do, your machine is going to do the bitwise AND with this particular IP address to define the destination network ID, to get the destination network ID. So let's represent this IP in the form of bits. So all 0, 0, 4 zeros, right? Then 0, 0, 0. So this is how you are going to represent this IP address in binary format, right? Now what is your subnet mask? /24. So it will be 1, 1, 1, 1, 1, 1, 1, 1, all ones. So all three octets will be all ones, and the last octet would be 0, 0, 0, 0, right? Now bitwise AND means if these are different bits, result will be 0. If these are same bits, result will be the bit only, right? So if you see, you will get this and all 0. So your destination network ID is 1.1.1.0, right? Now this network you don't belongs to this particular network, right? Your network is 192.168.1.0. Now your PC knows that to reach out to this particular network, I need to send my packet towards the router, and then my router will take it forward. It will deliver the packet to the destination, right? So now what your PC is going to do, your PC is going to generate the ARP packet. It will generate the broadcast for router, right? Because this is the fresh setup. First time we have booted all the devices. So it will generate the ARP broadcast for router IP address. So inside ARP request, you will see the target IP is this 1.1, right? So now let's go back to the presentation, and here you will see that now ARP request will be generated. It will be broadcast, right? To broadcast to different VLANs, you need to make sure that inter VLAN routing is enabled on your switch. Otherwise, you won't be able to see the routing. The routing of these broadcasts to the different VLANs. So as animation showed you that you have generated the ARP went to the enterprise router reply back with the MAC address of the router interface, right? And then your machine has generated the TCP SYN packet, and then that SYN packet has been forwarded to the facebook.com, right? So make sure that you remember this fact, that on each hop count your layer 2 information will change. Okay, your source and destination IP. So if I will talk about Ethernet frame, so you have Ethernet header, that is your layer 2 info. Then you have TCP header, IP header, right? And then you have your TCP header or UDP header, it depends which protocol is running on layer 4. And then you have your application layer, or you can say your data payload. Okay, so now, and we do have CRC, right? So now on each hop means wherever your routing device is available, on each hop this information will change, right? So initially, if your device is connected to switch on gig interface 1/1/1, right, and then you have your router, right, and then ISP, and then this is your Facebook. Okay, so when your packet will go from here, this SYN packet from your PC towards this switch, it will having the layer 2 information, source MAC of this client and destination MAC of this particular interface, right? So switch will forward this packet towards this interface. Now what router is going to do? Router is a layer 3 device, right? This was layer 2. So layer 3 device is going to read the layer 3 information, and in layer 3 information you have your source IP and destination IP details, and basis on destination IP, router will make the decision where I need to forward this particular packet. So we have default route for internet subnets. So your router will forward this packet through this exit interface towards the ISP circuit, or you can say ISP router, right? Now this packet will be having source MAC address of this interface. So your MAC address will change, source MAC address of this interface and destination MAC of next hop, whatever next hop your ISP has provided to this particular router. Because for internet, for internet subnet you would have entered the default route, and your default route says all 0 towards your next hop IP address. Let's say next hop IP address is this 112.1.1. This is your next hop IP, right? So you need to mention this. You need to update this routing here, that my default route says if my destination is all 0, send that packet to this particular IP address, right? And then that particular router will take it forward. Okay, so on each hop your MAC addresses will change. Your layer 3, layer 4 and data payload, this information will remain intact if there is no NAT device in between. Okay, if we don't have any NAT device, this information will not change, only your Ethernet information will change. If we have the NAT device, then whatever NAT configuration you have done on your device, accordingly your source IP, destination IP will change. Okay, now if this VLAN 10 PC would like to communicate to the DMZ network, right? So it will again, let's say you have internal URLs. So again your domain resolution will takes place, right? You will get the IP address from your local DNS server. Then this PC will send the packet towards the router, and then if you have done the routing properly, router will forward this packet towards the DMZ network, and then your TCP SYN packet will reach to the servers which are running inside your DMZ network, and you will get the reply, right? Similarly, if you want to communicate to your headquarters, so you will forward your packet towards the enterprise router, and then router will forward towards the MPLS circuit, and from there the packet will reach to your headquarters. Okay, so now if we will discuss about the modern network packet flow, that is your SASE. Now SASE is your secure access security, secure access service edge, right? And these days, earlier we used to have firewalls as well. Instead of enterprise router, you could have firewall for internet circuit. right? And for MPLS you would have MPLS router, right? That was the legacy way of doing packet forwarding. These days we have cloud service providers, we have cloud security gateways, right? So we don't need firewalls on your branches anymore, right? With the help of the cloud security providers, we can secure your communication. We can provide you inspection when you are going over the internet and SaaS applications, right? And if you are accessing your internal applications as well, we can provide you security. So now your security piece has moved from branch to cloud. Okay, so here we have represented SD-WAN edge, the branch office, which is connected through SASE POP, the secure access service edge point of presence, right, with the help of the SD-WAN gateway. And similarly, your remote access users are also connected with the help of the software to this particular secure access node in the SASE POP, right? And this SD-WAN gateway is also connected to your Velo edge in your data center, right? So that you can get access to your internal applications, as well as when you go over internet and your software as a service device, applications, your traffic is being inspected by a cloud web security engine, right? So let's have a look on the packet flow. So if it is coming from the remote user, it will go like this, right? And if it is coming from the branches, then it will go like this. So let me explain this in more detail. So it's like this. Earlier we used to have everything on branch, over branch. So we used to have complete LAN environment. We used to have MPLS router, right? And then we used to have internet circuit, or you can say instead of internet routers, we used to have firewalls in place for internet traffic, right? ISP, and this was your provider end of MPLS circuit, right? This is how our traffic used to flow in legacy networks, right? But these days what is happening? We have SASE, secure access service edge. Now SASE is combined with SD-WAN plus SSE, secure service edge, right? So in digital world, you would need, because now we don't need MPLS anymore, right? We can use internet for site to site connections, and we are working from homes, right? We are using internet to access our internal applications as well as our SaaS applications. Now it has become really challenging for legacy method to provide us the security without latency, right? So that's the only reason we have SASE in picture now, cloud-based security solutions, and SD-WAN on devices. So right now what happens, over branch you just have one SD-WAN router, and you have your LAN segment connected to it, right? Whatever your DMZ network, and from this particular SD-WAN router you have your ISP links, right? You have internet connectivity, and let's say you have the cloud service provider, and here we are using Zscaler. This is Zscaler POP, right? So what you are going to do, you are going to establish tunnel with this particular Zscaler POP, right? And from here your packets will go to internet and SaaS applications, right? And SaaS. So what has happened? Your local breakout, which was this initially, has changed, and your local breakout has become Zscaler now. So what is happening? Your packets are coming from LAN, from DMZ, they are coming to this SD-WAN device, and this SD-WAN is sending them over the overlay towards Zscaler. Zscaler is providing you the inspection which your firewall used to do, and then after inspecting it, it is sending it over to the internet or your SaaS destination, and then similarly your replies are coming back. So now your local breakout from site, this was your local breakout earlier before cloud security solution, but now your local breakout is Zscaler, right? So if you do what's my IP, after migrating to Zscaler service, you will get IP address from Zscaler data center, wherever we are applying the NAT. Earlier you used to get the IP address of this interface. I mean, whatever NAT pool we used to have, from that NAT pool you used to get the IP. So this is your SASE packet flow. Okay. So I hope you like this video. We have a dedicated course for TAC security, TAC foundation and network security. So I will provide the link in the description. You can go through it and you can check it out, and do share your feedback in comment section and like this video. Thank you.